All right, so I started recording. Let me share my solution to the two problems. So let me. There are many different ways of implementing things, you know that. Okay, here I can't go through every line of code. Obviously, it will take too much time, but I will give you a sense of what I have done. Right here, let's go to user interface. User interface, I have updated the constants, added a new one called remove member, and then changed save and exit to 14 and 15. I updated the help screen, and then I have under the process method, I have a case for remove member, and I call this method called remove member. So remove member is here. The reason it doesn't appear at the end is because I added more methods. I modified the main, I added another method to test just remove member. So so I have three methods added or modified. So you only have remove member, right? So that goes at the end. So remove member gets a member ID and then calls this method called delete member. It could be called remove member. And then it looks at the return code and prints different things depending upon what the result code is. So I didn't add a new result code. Some of you did, that's fine, either way. And I added two fields. One is called number of holds and the other one is called number of issued books to the result object. And I have this method to test remove member so that I don't spend an inordinate amount of time testing everybody. So I have a few members and books added. I checked out books to a member, placed holds for another member, etc. And then I interactively try to remove one of three members in each test. So that is how I tested. This is not all that important. This is how, just to show you how I tested your programs. Then library has a method that I called delete member. It gets a request and then it is searches for the member. And then if there is no such member, it says there is a problem and returns that result. If I added a few methods into member, just as I would do it if I were in an exam. So, I mean, so this is pretty much what I would do if I were to take this exam. But if I were to design it from a more from a longer perspective, I might change my design. But this is what I did when I took the exam myself. I have a method called get number of books issued, books borrowed.size. Some of you checked books borrowed against null. That is not true. It is books borrowed.size that should be 0 for number of books issued. Then I put a method called remove all holds. So books on hold.size, I just created a field here, not a field, a variable here called size. that remembered the number of books on hold, and then I cleared that list and returned that value. So this is the number of books the person had, and I'm removing all those holds right here. Then let's go back to library. If number of books issued is greater than 0, I have a operation failed result for the user interface, and then I put in the number of books issued into a field in the result, and I return the result. Otherwise, actually, this is not quite right. I shouldn't be. This is what I had initially, and it doesn't work. Actually, this does work. Yeah, sorry. I had a slightly different piece of code that didn't work when I tried. So, but this is the correct code. It is not enough to simply remove all the holds. And in fact, I think I forgot to do that here. Yeah, actually, I'm doing it. Yeah. All right, what I'm doing is I'm figuring out all the holds for this member and removing those holds from the book or corresponding book objects. This some of you forgot to do. So if you didn't do that correctly, you lost a point. It is not enough to just remove all the holds from the book side, from the member side. You have to also remove them from the book side, because they are two different lists. So the hold object gets destroyed only if all the references to the hold object are made null. And then I remove all the holds for the member, and I get the number of holds, and then I assemble the result and return it. That is what I do. I remove the member here. So I need a new method called member list, called remove member in member list, right? Which is very similar to remove book in book list. So I copied and pasted and adjusted the variables here. So it was a very simple task from getting this method here. So that is the first question. Any comments or questions about that? Obviously, some of you implemented in a different way. That is perfectly fine. I didn't impose anything special except sticking to certain fundamental guidelines, saying things like you have to use request and result to communicate between user interface and library, that the design should be similar to what we have already done, and those kinds of things. But whether to introduce a method in member or not of a certain type, that is entirely your call. The second question, in case you don't have any questions, is here. I'll show you the answer. Essentially, we have an if-else statement in converting. And I told you that there will be a question on converting conditionals to polymorphism, and this is that question. The second question was supposed to be converting from conditionals to polymorphism. So what you needed to do was create 3 subclasses, one for GIF, one for JPEG, one for PNG. Some of you added extra types. That's perfectly fine. But if you simply had a conditional like this, you didn't get many points. So what I did, again, there is no unique answer for this. In fact, I will show you 2 approaches. Some of you did one approach, some of you did the other approach. As long as it is a reasonable design, I have given you points. So let me show you one of the 2 answers I had. This is what some of you did, and let me close so many of these. So there's okay. So I have, for example, okay, I have a superclass called converter, and it keeps track of the source and the destination formats. And so it could, I have subclasses like GIF to standard, that is, it converts the GIF format to a standard format. That is what each of these would do, standard to JPEG. So they all subclass this converter, right? So that is one way of doing it. A perfectly valid way of doing that, which some of you did, was this way. And in fact, I think if I were to do this from scratch, this might be what I would do. I would probably have one class for each type of picture. So I have a superclass called picture. Okay. And it stores the data for that type of picture. So I'm assuming that every image file can be stored as an array of integers. That is what we assumed in the problem. And so a picture would have that field, and it will have a method to convert to standard. So every picture type like GIF or bitmap or whatever, PNG, they can be converted to the standard format using this particular method. So there is a standard picture too, but it is not really a picture class. Okay. So this is just a standard. There is no picture of this type. This is just a vehicle for conversion. So it doesn't really extend picture. Okay. So I have say GIF here. It extends picture, and there is a method to convert to standard. So it takes the data gotten from the superclass. So there is a picture. You remember this picture? It has a getter for the data. This is basically nothing but a getter. So the GIF class gets that data and converts it to some standard form. All right. The details, of course, we are not worried about, and then creates a standard object and returns that. And what I have done in this particular approach is to have a static method in every one of these classes like GIF, JPEG, or PNG to convert from that format. For example, here we are looking at PNG. I'm converting a PNG to, rather, I'm getting a PNG file from the standard format. I cannot have this as a instance method. So if you look at many of these designs in the Java libraries, they have methods like this. I have a PNG class, a class called PNG, and it has a static method that gives you a PNG object from some other format. So given a standard picture, it will give you the PNG file, and it has to be static because there is no PNG file to start with, right? So you would call png.get PNG from standard. As you are using these Java classes, you should see the static methods that work like this. So this is very much what very much like what we have in the Java development kit in many classes. Many of them have static methods to get an object of that type from some other source. So given a standard picture or a picture in a standard format, it will create a PNG using the data that the standard format has. So that is this is another way of doing things, and some of you, curiously enough, more than one of you, it is very strange that multiple students make exactly the same kind of mistake in an exam. I'm worried about those kinds of things, but I'm not pursuing it. You had classes like these defined inside this public class convert from standard or something. I mean, you took one of these classes and then started defining classes inside this. Please stop doing these kinds of things. Put classes independently unless there is a very good convincing reason. Nested classes are done, are there, you do create them, but why would you want a nested class for this? There is absolutely no reason to put a GIF class inside convert from standard or a PNG class. It doesn't make any sense. And I'm surprised that so many of you, 3 or 4 of you, had exactly the same answer. That worries me quite a bit. Okay, you should do things independently, right? Okay, that is the exam. Any questions? Anybody? All right.
What was the class average on the exam?
Okay, let me see. I mean, that might be a worry for some of you. Okay, let me see what it is. I didn't, I should have taken a look at it. Okay. The average for the programming part was pretty low. That I'm sure. Let me see the average for, give me a second. Okay. I'll tell you in a second.
Are you able to curve the grade for the exam?
Once again, it is 62 for the entire exam, the average. It's a bit low. I'm very worried, especially given that I would have a question. I had said that there would be a question on converting from conditionals to polymorphism, and very few students did that correctly. Maybe 5 or 6 students, or maybe a little more than that. But some of you just simply ignored that question. I am wondering why.
It's for some of us, it wasn't that we didn't know it, it's that we didn't have time. By the time we got done with the first question, we were just getting started on that. I had maybe 10 minutes work into that when you came on and said that 10 minutes after is coming up, and if we haven't submitted by then, we're going to lose a point for every minute after. At that point, I was just like, screw it. I'm not even going to do part 2.
Yeah, that is probably a valid point. I will also mention that maybe I'm just guessing here. some of you are doing the multiple choice questions by creating programs and then writing programs and then plugging in code and seeing whether they would, what the answer might be. If you are doing that kind of stuff, you will not have enough time. I'm not saying that the exam was very short, but if you could finish the multiple choice questions in an hour, then you had 2 hours for the programming questions. But I will do one thing, okay? I will make this offer. There will be one question. I won't say what question, what type of question it is, on the material for the second. Actually, I will say what it is. It would be taking, I'm not saying it is going to be exactly converting conditionals to polymorphism, but I will put an extra question in the final that will, whose grade will replace the grade that you have for the second question. I rarely ever curve things, because curving grades is an admission of defeat. I don't like that. I want students to learn, but I would be very happy. In many classes, I have offered a makeup question, not makeup exams, a makeup question for topics that I wanted students to learn well. So I will give you a question on redesigning a program, okay, to make it more object oriented in the final. And then you might ask, where is the time? I mean, the answer is this. I'm going to a conference in New Zealand the week of the exams, so I will not be able to, I'll be giving this as a, what do you call, more like a take-home exam than anything else. I expect you to honor student code of conduct and do this independently. I will make the exam due by, what if I made the exam due by an hour later than usual or something? Would that be too much pressure, too much interfering in your schedule? I will have an extra question that will replace the grade for the second question. Okay.
Professor,
Yes.
we are comfortable with our grade on the one from midterm 2. Will our final grade replace that still, or will it be the highest of the 2?
Highest.
Okay, thank you.
Yeah, you will not be penalized for doing or ignoring that question. It will be a bonus question. If you didn't submit the second question, then it is definitely worth doing that. Some of you got 25 out of 25 for that question, maybe half a dozen of you. You can safely ignore the question in the final. Okay, you don't have to worry about it one bit. But what I am asking is, supposing I said the exam is between, let's say, 6 and 10:30 or something, would that be saying it is not fair? If anybody thinks it is unfair, please speak up now. Or
PM?
Sorry?
PM? Is that when
Yeah,
6 to 10
PM, yeah. Oh, sorry. Oh, we are having an afternoon class, right? Yeah, I forgot. I keep saying, oh, sorry, 1 to 5:30 or something, or 5:20 or something like that, an extra hour. I'm having difficulty computing now. 1 to maybe 1:10 to 5:10. Would that be saying, look, I have work starting at 4:30 and you are you're putting me at a disadvantage, you're not being fair or something, then I will be in trouble. Okay.
Is an extra hour to accommodate for that extra question?
Correct.
Okay. So essentially, the third exam is gonna have 3 coding questions, or
Yeah, could be. Yeah, it might be. You
Or
might have
2.
4. I mean, I will try to make sure that your coding questions for the real exam 3 would be done in 3 hours. So you'll have 1 hour for this question. That's what I'm saying.
okay.
And my question is, I don't want to I don't want to say that you have to be there till 5 o'clock, because I'm not allowed to say that. I mean, the administration might give me a hard time if I said you have to be here till 5. I can only ask you to be here till 4:20. So if you cannot be here till 5, then I'm not going to do this. All right. And I cannot give unlimited time. That is not what I have in mind. Or I could do an hour of that is another possibility. In week 14, I could ask you, I could give this extra question as in the final hour. You can finish the class exercise by that time and do this question in the final hour if you want.
I would prefer that.
Okay, I think that is probably going to make more sense, because you'll be very tired taking a 4-hour exam. So let's do this. In week 14, let's say from 3:20 to 4:20, roughly, you will get 1 question. If you want to answer that during that hour, go ahead and do it. Otherwise, feel free to leave. Okay. There would be no penalties for not taking that, for not answering that question. If you answered it and got a 0, nothing is going to happen. Even if you got whatever grade you got, I will take the maximum of the 2 grades for the second question and the.
So is this assuming that we get done with the class exercise by 3:20? Because
Correct.
our group
Correct.
usually doesn't
Correct.
get done
Yeah.
till the end of class.
Well, there has to be a compromise somewhere, right? I cannot think of anything else. Okay, do you have any ideas? I will probably not do a lecture. I'll simply give the class exercise right away. I assume that everybody would be reading stuff and then coming to class. That is how it should happen. If anybody has a better idea, I'm open to those ideas.
I've got a question.
Yeah.
I think I answered question 2 completely, but I
Mhm.
turned it in 4 minutes late, so I got -4 points. Can I get those 4 points back if I do it all correct again? And
Yeah, sure.
oh, okay.
Yeah, of course. So does anyone have an issue if we had a bonus question, not a bonus question, a makeup question in week 14, in the last 60 minutes of class? You will have to then turn in the class exercise by 3:20. Okay. Nobody's objecting, so I'm assuming that is okay. All right.
The class exercise is due at 3:20.
Yes.
Okay.
Well,
we
I will make it due at 4:20, but then for those of you who don't want to take the makeup, I will make it due at 4:20. But if you don't finish things by 3:20, and if you want to take that exam, then I don't know what you will do. Okay. But if you don't want to take that extra question, then you have until 4:20.
Wait, I'm confused. Sorry.
Okay. I will not lecture in week 14. Okay. Normally, you should have watched all the videos, gone through all the reading material, taken the quiz, and then be coming to class. The class is simply to reinforce some of those ideas. So week 14, I will not have that lecture. I will simply give you the class exercise. You will have 2 hours and 20 minutes to complete it. Okay. And then take the bonus question from
Also,
4:20. If
so
you don't
boom.
want to take that bonus question, you have until 4:20 to finish the class exercise. In any case, you have until 4:20 to do the class exercise. If you, I mean, at 3:20, you have the choice of working on that particular problem that I will be releasing at that point in time. If you don't want to do it, that's perfectly fine.
So essentially, that bonus question to make up for exam 2 is not going to be on the same day as the third exam. It's going to be on the day of week 14.
Correct.
Okay.
I don't know of any other way of accommodating this. If anybody has a better idea, I would be very happy to consider it.
The
But
only
it has to
other
be-
option that I could think of that would be much more flexible for all of the students would be, instead of having the programming question in content, the programming question is in something similar to a quiz or exam, where as soon as we open it, a timer starts. We open it, we can read what we have to do. A timer's already going. We have until that timer runs out to implement it and submit it. And
You
then
mean-
that way you could make it available anytime
Mhm,
during this day, whatever is convenient for the student. When you have time, you can sit down, you know, you have an hour for this, you can start. And until they actually open that up to read what they have to do, the clock isn't running. As soon as they open it up, the clock's running. Do what you have to do, make sure you submit it before the clock runs out.
Yeah, I think that makes sense. I can do that. But I would strongly, that is, you have to be very disciplined not to do other things. Of course, that is true even otherwise. But I mean, if you have the class exercise still not submitted, don't be tempted to go and do the class exercise. And I will put everybody in a separate, that is another problem. How you'll have to do the class exercise independently then. Okay. If I'm going to make the exam available to you at 1 o'clock, then the class exercise will have to be independently done, because I don't know who is doing what at any given point in time. All right. And remember that I mean, maybe the score in the class exercise will not be substantially different if you were to do it together or in isolation. The difference may not be substantial, but do you really want to do that independently just for the benefit of what do you call, having that flexibility? Anyway, think about it. We will decide next week, okay? Because I don't want to take up class time too much, but we will decide on one way or the other next week, okay? But I want you to learn. That is the reason I am giving this bonus question. I am unwilling to curve things. You have to learn and apply these concepts, because you cannot be at 141 level at the end of 372. The instructor in 472, 499 was saying that I'm not doing a good job teaching certain concepts, including FSM modeling. I don't know. I mean, so I'm very worried. Okay. All right. We will make a decision next week. Think about how you want this to be done. We'll take input again and spend maybe 10 minutes discussing it next week. All right. Okay. What I want to do is go over the microwave design and implementation. I think in the interest of time, the best way to do that would be to just look at the source code now, because we don't have time to go through all the PowerPoint slides. It is much better to do this through the source code, and the class exercise will have questions on the source code. So you will need to download a file, which is the second implementation of the microwave. Give me a second. So you'll have to download that in order to do the class exercise. I am going to share the source code, parts of the source code. Obviously, it's a pretty huge program. It has many classes, but most of the classes are very short. So it is, if you see one class, then you will see maybe 3 or 4 more classes that are exactly like that. So you don't have to look at every class to see the architecture, the design. Okay, so I'm going to share my Eclipse screen, and then I will show, I will talk about the approach, the design, and the implementation all together. That is the only way we can do things in a reasonable amount of time. I'm going to, let me share here. Okay.
Is the source available for download yet or no?
Yes, it is. If you go to class project implementations, I think you will see 2 versions of the microwave. I think one of them should say version 2 or something. And that is what you should download. Okay. I assume you can all see my Eclipse window. There are 5 packages here. This is a Java FX program too, but it's not the FX thing that is interesting here. And we saw that this microwave has 3 states: cooking, door closed, and door open. Okay, just 3 states and 5 events. So we have what is called a state pattern. We are going to have one class for each state. So if you open or if you expand this package states, you will see cooking state, door closed state, and door open state. So the idea is that for every state in the system, we have one class. This is called the state design pattern. Okay. It's one of the most important patterns in the Gang of 4 book. So for each state in the system, you create one concrete state, and then we have a abstract state called a microwave state. So the microwave state looks like this, abstract class microwave state, and there is one method for each event. What do you want to do when the door is open? What do you want to do when the door is closed? What do you want to do when the timer ticks? What do you want to do when the timer runs out? and so on. So for every one of the 5 events, you can see there is a method here, and each method body is empty, meaning you do nothing in the default case. Okay, and before entering a state, you might want to do some initialization. So there is an enter method that you need to implement for every state. And after leaving a state, you might want to clean up some stuff. And that is the leave method. So there are 2 abstract methods and 5 concrete methods, 1 for each event. The concrete methods are for the events. And each state determines for itself what it wants to do. Let's look at the cooking state. That is the most complicated one. Cooking state extends microwave state. We will see the other stuff in a minute. It is a singleton because there is only one cooking state, right? And you can see that it implements on cook request, on door open, what to do. Oops, I had this capitalized. I can't believe it. Anyway, anyway, that's a minor. I mean, I shouldn't have it as capitalized. What do you want to do when the timer ticks? What do you want to do when the timer runs out? So when you are cooking, when the microwave is cooking, what do you want to do when the door is opened? What do you want to do when the timer ticks? What do you want to do when the timer runs out? So there are all these event handling methods. So it is up to a state to decide what to do. Notice that there is no method here for door closed. On door close, there is no method here because the door is already closed, so I am not going to worry about it. So if you try to close the door while the cooking is going on, if you could do it, if you press the door close button, you will do nothing. That is the default action. And what do you do before you enter the cooking state? Here is the code for that. This is the code that gets called when you enter the cooking state. What you do is you create a timer that runs for 10 seconds. It should really be for 60 because the cooking time is for 60, but while testing, I don't want to wait for a minute. So I'm just making it 10. Then I need to display some stuff on the GUI. So I have a class called microwave context. Whenever you use the state pattern, there is going to be a context class. So you can call it microwave context or anything under the sun, it doesn't matter, but better put the word context there so that it is clear to the person who is looking at the code that this is the context class. And this context class stores anything that is to be shared by the states. The states are not going to talk to each other in any serious way. Anything that is common should be put in the microwave context. All right. So the only serious thing that we have here are the current state. That is the most important thing. And of course, the context has to keep track of where the display should go. So that this is a FX window. I'm not going to spend much time on that. So this is a display where the messages will go. The current state is quite important, and that is the current state of the microwave. So it could be cooking state, it could be door closed state, or it could be door open state. This is a singleton, so I'm not going to go through the code for that, making it a singleton. And this is a pretty important method, a very important method, in fact, change state. So we are implementing state changes in a localized way. For example, going back to the cooking state, let's say the door is opened. If the door is opened, this method will get called somehow. You will see how. And we will call this method called change state in the microwave context. So the microwave context is here. We are going to call change state here. And this will say the new state is whatever state you pass here. What did we pass from cooking state? When the door is opened, we go to the door open state. There is only one instance of it. So we get that instance and give it to the change state method. So microwave context will say the new state is now door open state. Before doing that, it will call the current state's leave method. And then after changing the state, it will call the new state's enter method. So the current state's leave method will be the leave method of cooking state for the situation we are talking about. What it will do is it will stop the timer. The timer is set to null. It will tell the microwave context to tell the display to show that it is not cooking. It will tell the microwave context to show that there is 0 time left for cooking. So this is cleanup or post state actions. While leaving the state, you have to show that you are not cooking. You shouldn't have a timer at all now. There is a timer object, which we will see in a minute. That timer is created when we enter and killed when we leave. Okay. So when we enter, we are saying that we are showing the cooking that we are cooking, and we show the time left as the initial value. So whenever we enter the state, we show the initial time. Any questions so far? Okay, let's finish the microwave context, because it's probably one of the biggest classes, and it's only probably 200 lines or less, 164, around that. It's not very long, but still the longest one in the system, I think. At least one of the 2 longest. Okay, the methods are very, very simple. What do you want to do when the cook request is made? You call the current state's cook request. Let the current state decide what to do. Okay. If the current state is door open, it will be ignored. If it is door closed, it will start cooking. What do you want to do when the door is opened? Let the current state decide. So the code is extremely simple, you can see. These methods get called when events occur. So all events are directed to the context, except the timer events. The timer events go directly to the state that created the timer. There is only one state that creates the timer, and that is the cooking state. So the cooking state creates a timer. Let's look at that. Or before that, I just wanted to point out a few other methods here. Then we will see the timer. These are methods that are called by the states to change the display. For example, the display might say, the state might say, I don't want to show that we are not cooking. I want to show that we are not cooking, right? So like when the door is opened, you want to display that we are not cooking anymore. So the door open state might call this method, or in fact, it will call this method show not cooking, and display dot. We are calling the displays show not cooking, and the display would simply change the text field to say that it is not cooking anymore. These are very simple things, but the idea is that the states will tell the context to change the display. You can see the rationale for it in the readings, right? Now let's look at the timer. The timer is going to use a clock. We have seen the clock last week before last. So I'm not going to go through this in any serious way. It is a thread that keeps sending out signals, but it doesn't, this is a very general purpose clock. It doesn't know who the signal should be sent. So it sends the signals to anybody who cares. So this is like a server, like you might be purchasing things through an online store, and the idea is that if you want service, you contact the store. If you want to be notified of a change in price, you contact the store. If you want to know of a new product, you register with the store, etc. So the clock doesn't know who its clients are, but a client can add itself as a listener. So this clock is an observable. It can be observed. And the clients are things that would register themselves through a method called add property change listener. So there is a class called property change support in Java that would keep track of listeners. So you don't have to implement all that functionality yourself. You simply have a field called property change support. And then, so you're using this as an adaptee. So the clock is an adapter. A listener would simply register themselves. So we have a property change listener coming. We don't know what the exact type it is. It has to simply be something that can be registered as a listener. And we simply add it to this field using this method call of property change support. I will show you, I'll make it a little more concrete by showing you the timer class. The timer class implements property change listener. So it can be a client of the clock. The clock is a server, right? So the timer implements property change listener. And when a timer is created, it registers with the clock.get instance. So the timer knows the clock. The clock doesn't know the timer, except as a client of some type, which it doesn't really care. So the timer calls the clock's add property change listener and passes itself as a parameter. So the clock class would, or clock object would send clock signals to this timer. And then when the client of the timer tells the timer to stop, the timer will tell the clock, I am not interested in any more notifications. So there is a remove property change listener. Just as you added yourself as a client, you are now deregistering you're removing yourself as a client from the clock when you are asked to stop by your client. So timer is a client of the clock, but the timer itself has its own clients, and that client is notified when the timer ticks or when the timer goes off. So when a timer is created, the client sends its own reference here. So this is a bit complicated. You can see here, the cooking state is interested in creating a timer. So it implements the notifiable interface. The notifiable interface is going to have two methods. I should have this as lowercase on timer tick and on timer runs out. So the cooking state is going to implement both of these methods. What should it do when the timer ticks? What should it do when the timer goes off? So the cooking state, going back to the enter method here, when it creates a timer, it passes itself as the first parameter. It has implemented notifiable. You can see that the cooking state has implemented notifiable. So the first parameter here is this. So this is a notifiable, and the clock requires somebody that can be notified. Where is the clock? Sorry, the timer class requires somebody who is notifiable. Here, I misspoke. It is a timer class that requires the notifiable. And the second parameter is the timer value. So it remembers, the timer remembers who the client is. In this case, it is the cooking state only. And then the time value is stored. And whenever the clock ticks, you can see here, it is sleeping for a second, and then it calls a method called fire property change. So this will notify every one of its clients. You could have any number of clients, they will all be notified in some order, which is not guaranteed. So the timer is a client, and it will be notified. And for that, it has to implement a method called property change. So you override the property change method of, which is a method in the interface property change listener. So you need to implement that method and see, and here you decide what you want to do when the timer ticks. If time value is going to be 0 after decrementing, you tell the client the timer has run out, and then you stop listening of clock ticks. Otherwise, you tell the client that the timer has ticked and give the current timer value. So this is keeping track of the timer value, the time value, and telling the client what the time value is. That is the most difficult part of this whole thing. The rest is fairly easy, okay? What we haven't looked at is how we get external events. How are cooking requests, door close requests, door open requests handled? For that, let's, for a couple of minutes, look at this. Microwave display is an interface. Okay, it is able to, anything that implements microwave display should implement these methods to display the time left, to display the light on, and so on. You can have a very sophisticated implementation of this that looks really like a microwave. I mean, spend maybe a few months developing that. Or you could do something like this, which is just taking a couple of hours to develop, which is just having a couple of text fields and so on, and a few buttons. So we create the GUI here. The FX program creates the GUI, and then it has, you can see there are text fields for, or text, text fields for doors, the status of the door, the timer value, light status, cooking status, and so on, to show what the microwave is doing. But it has also a few buttons, 3 buttons actually, one for closing, one for opening, and one for cooking. And they are all of type GUI button. Let's see that. That is pretty interesting. Not very difficult, but interesting. Let's look at let's look at GUI button. GUI button is an abstract class. It extends the button class, and it responds to clicks on itself. So when a button is clicked, the button itself handles the click. So that is done here. Set on action this. That is, if a button is clicked, this set on action is a GUI button, right? So if this GUI button is clicked, who handles it? This object itself. So let's look at cook button. It extends GUI button, and when it is clicked, the handle method gets called, and we call the contexts on cook request, because this cook button is only for requesting to cook. So what it does is it calls the context cook request method. Door close button would call, in a very similar way, call the on door close. When that particular button is clicked, it will call on door close. And on door open, the same thing. Now, that pretty much covers the whole thing. To run this, you should go to the main class and run it. I think I already have the things set up to run. Run as Java application. You know how to run a FX program. Oops, so you can't see the thing. So let me go ahead and change the share. Oops, what do you share? All right, you can see the GUI. There are a few text fields here, a few button fields here. So I can press close door. So this is basically, when I click on this close door, I am actually coming to this particular line here. Okay, so when I click on this, it is this line that gets executed. So the button itself is handling the click, and I am calling on door close in the context. So let's look at the context. Microwave context. And let's see where the on door close is. Here. What it does is it calls the current states on door close. What is the current state? I don't know. Suppose it is door open. Then we will be going to, sorry, that is the wrong one. Door open state. Door open state. Suppose the door is open and we press the close door button. Then we saw that we will be in the context, we saw that we are here. We are calling on door close on the current state. And if we are in door open state, we'll come here and we will change the state to door closed state. And we will come back to the context. And we will be calling door open states leave method, which will, sorry, here, door open states leave method, which will show that the door is closed. And that's all. And then we will change the current state to door closed state. And on door closed state, we will call the enter method. And what is that? Door closed. Maybe it is not there. Door closed state. We are going to call the enter method of door closed, and it says show the lights off.